Hello, we're going to talk today about Unit 4, which is our unit on lines, Day 7. So these are notes about linear transformations. And possibly in another math class, you talked about transformations of shapes, where you might have a rectangle or a triangle or something that you needed to move on a coordinate plane, or you might have shrunk it or enlarged it, you might have reflected it. So this is the same concept, but we are simply transforming a line. We are going to shift our line vertically. It'll go up and down, or we are going to, flipping your page over, shrink or compress, stretch or compress your line, which changes its slope. It is essentially a rotation of your line. So we are either going to change the B value or the M value. Desmos is definitely your friend when we are working on things like this, so you might want to open up your other tab into Desmos so that you can go back and forth and check out how Desmos quickly shows you a transformation of a line. All right, so basically a transformation is a change in the size or position of a figure. And so if we have a function, f of x, this is our granddaddy of all functions, right, where our slope is 1, we are going up 1 over 1, up 1 over 1, and we are crossing at the origin, so our b value is 0. If we shift it, you can imagine that we would shift the whole line up or down. It's going to change where we cross the y-axis. If we stretch it, you can think of that as if we had a point here and a point here, and if we currently have a slope of 1, if I multiplied the x value here by 3, I will now have a slope of, it's still at the y of 1, so I would have 3, 1. And if you can imagine that I stretch this guy up here by a factor of 3, it's originally an x value of 3, it's now going to be 9, so it's going to be way over to the right off the page. So we're either going to change our b or we're going to change our m. So first we're going to talk about vertical shifts. And so realize that when your b value gets bigger from one line to another, make that a little smaller. Ooh, not that much smaller. Hang on one sec. That's better. When your b value increases, it means your whole line is shifting up. And if your b value decreases, your whole line is shifting down. So I'm going to use these examples right here, but I'm going to click over to Desmos. So keep in mind, we're going to do y equals x minus 4 and see what happens. And we're going to do y equals x plus 3 and see what happens. Okay, so once I'm in Desmos, I'm going to put the original line in our paper that we just had. The original line was y equals x. And so here we are crossing through the origin, and we have a slope of 1. Okay, that's my original line. The next line that is suggested is y equals x minus 4. Okay, so my new y-intercept is at negative 4. You can see on here, no, I want my lines to be at 1. There you go. Okay, so this is at negative 1, negative 2, negative 3, negative 4. You can see that that point is at 0, negative 4. You know that if you went from the red line to the blue line, from the upper to the bottom, we went whomp, 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 whomp. We went down 4. Okay, also on your paper, you have y equals x plus 3. And so we want to compare these two lines. And if I go from my original line, which is right here where I cross at 0, whomp, 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 you can see that I went up 3 that time. So notice, I can take my b value of the new line, so let's just look at y equals x plus 3 right now. Take the b value of your new line and subtract the b value of your original line. 3 minus 0 is positive 3, so that means I went up 3. If I'm looking at my middle line here, x minus 4, I say negative 4 minus 0 equals negative 4. Since it's negative, it means we went down, and of course we went down 4. So feel free to play around in Desmos, because Desmos is very friendly, and you can change your slopes here, you can change your y-intercepts, and you can see exactly what happens to the line. Okay, we're going to go back to our notes. And so on paper, when it says describe how each line was transformed, as we looked in Desmos, we could see that we went from y equals x to y equals x minus 4. We could see that we physically went down. You can draw yourself a sort of approximate coordinate grid, and if you have some lines, 2, 3, 4. I'm only going to draw those vertical lines because I don't really care what's happening on the x-axis right now. Okay, so if I started at y equals x, that's that line. And now if I have y equals x minus 4, whomp, 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 that's my new line. Okay, they're going to be parallel, so they have the same exact slope. You can see that you went down 4. Okay, also I can take the b value from my second line, or my new line, and subtract my b value from my first line, and that's going to show me exactly mathematically what happened. Okay, my second line had a b value of negative 4. My first line up here had a b value of 0. So negative 4 minus 0 is negative 4, which means down 4. Your answer here, when you are asked to describe what happened, is you say it went down 4. Okay, on this one, our second b value was 3. And we're going to subtract our first b value. Sorry, I don't want to have that there. Our first b value, again, was 0 because we started with y equals x plus 0. So we're going to say second line b value minus first line b value. I'm going to say 3 minus 0 equals 3. Since it's positive 3, we went up 3. Okay, so we can find our transformation using a graph or using an equation. Okay, so if we want to look at these two graphs, we want to know what is the transformation that occurred from y equals 2/3 x minus 1, this is this line, that's my first line, right, to the y equals 2/3 x plus 2, this is my second line. And I know that because the problem told me that, okay? So to go from line 1 to line 2, womp, 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 I had to go up 3. I can physically see that, but I can also take my b sub 2 minus my b sub 1, and you can see that that is 2 plus 1, which is 3. So you know you went up 3 here too. The answer for that is up 3. Okay, given y equals 2x plus 3, write the equation of a line that represents a translation 6 units down. Let's give ourselves a quick 3, 4, 5, negative 1, 2, 3, 4, 5. So I'm giving myself a rough order coordinate grid, right? Cartesian plane here. So if I have one line that starts at 3 and has a slightly steeper slope than my original line over here, my granddaddy of all lines, my parent function. If I start at 2x plus 3 and I go down 6, 1, 2, 3, 4, 5, 6, my new line is going to have the same exact slope by definition, because it's the same exact slope, it's just translated down. You can see that the new b value is at negative 3. Okay, that's my new b value. So I would have y equals 2x minus 3 as my answer there. And again, you could just pop y equals 2x plus 3 into Desmos and physically count down on that y-axis 6 spaces to see where you ended up. You don't even have to do this kind of math if you don't want to. All right, so now we're going to think about vertical stretch or vertical compression. And I've included in our Schoology folder, I've included a different teacher's version of stretch and compression. They are pretty good because they describe why we would call this a stretch if we are getting a steeper line, and why we call it a compression if we're getting a more shallow line. So you can always take a look at those if you want to get more information. Steepness means that if the absolute value of m of your slope increases, we are getting steeper. If our absolute value of our slope decreases, we are getting less steep or flatter. Okay, and the reason we say that is because if you imagine that you have a negative slope compared to a positive slope, you know that one is going downhill and one is going uphill. So it's harder to see the values unless you think about the absolute value of your slope. All right, so a line becomes steeper if the factor that you're multiplying times m is greater than 1. Okay, and so if I start out with a line like y equals x, and I multiply by a factor of 1/2, right? I've multiplied my original m by 1/2. I know that my new line is more shallow. It is flatter. It is less steep. And so you can draw those right in Desmos and take a look. Let's do that. All right, I'm going to start with my parent line of y equals x. And the next line they gave me, y equals 1/2 x. You can see that that second line is less steep. So if my original slope was 1, which we don't normally write, and I multiply by a factor that's less than 1, my new line is going to be less steep. Okay? On the other hand, you can see that your other example on your paper is y equals 4x. This time I went from 1 to 4. So if you multiply by 4, that factor multiplied by 4, 4 is greater than 1, and you can see that my new line is much steeper. Okay. Again, Desmos is your friend here, so you can just type in your equations and look and see exactly what happened. I'm going to remove our parent line here for just 1 second. If we have y equals 4x, and then we also have y equals negative 4x, you can see that one is a downhill slope and a negative slope, the other is a positive slope. So this is a case where if we had to compare which one was steeper, 4 and negative 4, they're the same steepness, it's just that one is reflected over the y-axis. Okay, so back on our notes, we've talked about what happens when we go from y equals x, that's our original line, to y equals 1/2 x, and we know that we got flatter, and for flatter we're going to say that's a compression by a factor of 1/2. So by 1/2, that's because I took my original slope and I multiplied it by 1/2. Okay, so it's less steep by 1/2. Less steep or flatter. Okay, if I went from y equals x to y equals 4x, that's a stretch, and we multiplied the original slope by 4 to get our new slope. So it's a stretch by 4, or you can say it is steeper by 4, and I'm saying by 4 meaning by a factor of 4. All right? So if you're given the actual factor that you're going to use to change your slope, you're just going to multiply your original slope by that factor. But sometimes, and you'll see this on your notes, sometimes you are actually given two lines and you have to figure out what happened, what we multiplied our slope by, and so then we have to describe the transformation that occurred. So we're going to look at number 1 here. I have y equals 2x plus 1 and y equals 6x plus 1. First of all, I can see that we didn't shift, right? Because both times we are in exactly the same space on our y-axis. I did go from 2 to 6. So in my mind, I know that I multiplied 2 times 3. So I'm going to get steeper, or stretch, by 3. But sometimes when you get numbers like this, it's not an obvious thing that you can do in your head. So the way we find our factor is from the new line, m from the new line, divided by m from the original line. And you can see that our m from our new line was 6, our m from our original line was 2, and that's how we get our factor of 3 if it's not really obvious and we need to algebraically figure it out. Okay, so here I have y equals x plus 2, y equals 1/4 x plus 2. You can see that you did not shift, you're still in the same location on the y-axis, but we went from 1 to 1/4. So that's a compression, or flattening, compression by, what did I multiply by? I multiplied by 1/4. Right? Look at number 3, you can see that we actually change our location on the y-axis, and so we have a shift, but we also change our slope. So we have a shift and we either have a stretch or we have a compression. So we're going to have to do some fancy math to figure that out. Okay, remember to find my vertical shift. it's the second b minus the first b. So it's -3 minus 1. So my vertical shift is -4. I went down 4. Okay, and then for me to figure out my change in slope, I have to figure out what did I multiply times 1/3 to get to 3. That is 3 divided by 1/3, which is 9. So I know that I have a factor greater than 1, so I stretch by 9. And remember, I did that by saying 3 divided by 1/3, which is the same as 3 times 3. Okay, try 4, 5, and 6 on your own. Look and see, is there a vertical shift? Is there a change in the slope? Are there both? And describe exactly what happened for each one of these. Okay, when you have a stretch, you're getting steeper. And when you have a compression, you're getting flatter. If you have a vertical shift, you're either going up or down. Okay, try 4, 5, and 6 on your own, and then come back and check your work. Okay, so if you check your answers for 4, 5, and 6, with 4 I could see that I did not change my slope, I only changed my y-intercept, and so I started at +5 and went whoomp, whoomp, whoomp. I went down 9 to get to my new line, and so the change was -4 minus 5 is -9, which means down 9. For problem 5, I didn't change my y-intercept, but I did change my slope. I went from a steep slope of 6 to a slope of 2. So I'm getting flatter, and I take my my new line's slope and I divide it by my original line slope. So I have a factor of 1/3. I'm going to say that it's flatter by 1/3 or it had a compression of 1/3. Make sure that you give me the actual factor on homework or a quiz. Don't just say it got flatter. Okay, and again, plug that into Desmos if you need to see what happened. When I went from y equals 1/4 x plus 3 to y equals 4x plus 3, no change in vertical location, but we do have a change in our slope. So I took my new slope divided by my old slope. 4 divided by 1/4 is the same as 4 times 4. So I stretched or got steeper by 16. That got steeper. Make sure you give me the... Make sure you give me the number. All right, finally, if the equation of a line is y equals 1/5 x plus 7, and that is translated 4 times steeper, that means I'm going to multiply my slope by 4. So my slope is going to be 1/5 times 4, right? So my new slope is going to be 4/5. Okay? If it's stretched by a factor of 4, I expect it to be steeper. So I want to plug that in and just double check and make sure it looks like it's steeper. My new line is going to be y equals 4/5 x plus 7. So let's just plug those both into Desmos and make sure that we agree that we got steeper. All right, so here we are in Desmos. If I graph y equals 1/5 x plus 7, it's going to look like that. And if I graph y equals 4/5 x plus 7, that is my second line, and that is definitely steeper. All right, so be sure to look over your study guide and make sure you have all of your homework taken care of for this unit so that you can be well prepared for your unit test.